everybody, my name is Pamkila Su, and I'm currently a postdoctoral researcher in the Department of Communication Science and Disorders at the University of Delaware. Thank you so much for coming to our virtual technical session as part of the 2021 ASHA Convention. We'll present on our recent work titled An Empirically Based Typology of Spanish-Speaking English Learners. This research is supported by a grant jointly funded by the NIH and IES. The presenters do not have financial or non-financial relations related to the content of the session. So here's the outline for our presentation. We're going to start by providing some context for this work, and specifically I'll talk about why we would expect to see some heterogeneity within a bilingual sample, and why it's important to understand this within group variability when we're working with bilingual children. And then we'll talk about the method. Specifically, we use something called a latent profile analysis. So we'll talk about that, and now I'll walk you through our findings and discuss some clinical implications. I have listed the learner objectives on the right, and I would encourage you to come back after our presentation to check your understandings. Hello everybody, my name is Pamkila Su, and I'm currently a postdoctoral researcher in the Department of Communication Science and Disorders at the University of Delaware. Thank you so much for coming to our virtual technical session as part of the 2021 ASHA Convention. We'll present on our recent work titled An Empirically Based Typology of Spanish-Speaking English Learners. This research is supported by a grant jointly funded by the NIH and IES. The presenters do not have financial or non-financial relations related to the content of the session. So here's the outline for our presentation. We're going to start by providing some context for this work, and specifically I'll talk about why. So in addition to common individual variability that we would also expect in bilinguals, just as we would expect in monolinguals, there are three additional sources of variability specific to bilingual children. So first, the onset of exposure to a second language would be one source of variability. So some children are exposed to two languages from birth, what we would call simultaneous bilinguals, whereas other children are first exposed to one language, make significant progress towards learning that language, and then start learning a second language, what we would call sequential bilinguals. So the onset of exposure to a second language would impact their language ability in each language. A second source of variability that would introduce additional complexity is the amount, so quantity, and the quality type of language input in each language. So amount, you can think about it as raw frequency. So for example, some families may provide more language input compared to others, or you can also think about it as a percentage or distribution across two languages. So 50-50 versus providing language input in predominantly one language and a very little other. And then type of language input, you can it would reflect the quality of input. So like the context or the activity used each language in, the complexity of the language that you're providing, or another example would be diversity of vocabulary in your language input. So all of those quantity and quality aspects would impact a bilingual child's language ability. Additionally, depending on the two languages a child is learning and how similar those two languages are, those two languages might interact with each other to different extents, which would also introduce additional variability. So because of these different sources of variability, bilingual children is not a monolithic group, and we need to consider the within-group variability in this group of children. So far, we have talked about the broad group of bilingual children, so any child who is exposed to and learning two languages. There is a subset of bilingual children who are referred to as English learners. These children are students whose native language is a language other than English and who is designated by their school district as having limited English proficiency. Now, these students are placed in a variety of educational programs designed to instruct the requisite English skills to eventually demonstrate grade appropriate academic achievement in English. Generally speaking, these programs can be characterized as either dual language programs that focus on developing students' proficiency in both languages, or English-focused programs that provide English academic instruction to improve English proficiency only. A main difference between these two programs is the division of instructional time between English and the home language. And we care about heterogeneity, and it's important to identify dual language profiles in English learners for both educational practice reasons and for clinical considerations. So educationally speaking, regardless of the goal of a specific educational program, A program can only be effective when there is congruence among the specific goals of a program, teachers' use of instructional language, and linguistic needs of the children in the program. So, for example, if you place a child with extremely limited functional English ability in an English immersion program where the teacher only uses English, that may actually restrict the student's access to the educational content, so not a very good match. Or if you place a child whose parents would like them to improve both languages, if you place such a child in an English immersion program where the teacher only uses English, that also wouldn't be very effective in achieving student and their parents' goals. So if Spanish-speaking English learners exhibit distinct language profiles, identifying these dual language profiles will facilitate the placement of English learners into appropriate educational programs so that the instructional language can align with the specific types of students' linguistic need. Clinically speaking, understanding language profiles, dual language profiles in this population may help identify Spanish-speaking English learners who may be struggling in both languages early on so that their progress in both languages can be monitored and an intervention can be initiated when needed. Between 2015 and now, there has been a small body of literature examining language profiles in Spanish-English bilingual children. We identified 5 studies on this topic. These studies vary regarding the age of the participants, the domains included in the profile, and whether one or both languages are considered in the analysis. So we summarized current evidence in the format of a table and presented part of the table here. For those of you who are interested in specific findings from each study, there is a link down below here that to a preprint that you can go to read more. So you may notice that across these studies, most studies focus on preschoolers, with very little work on school-age children, so there's only one, and they included only one language. And then most studies considered more than one area, so they included not just language, but also cognition and literacy in the analysis. Helping et al. 2021 is actually the only study that focused on just oral language skills, and they used a sample of 161 preschoolers. So there is a need to understand the presence of dual language profiles in Spanish-English, school-age Spanish-English bilingual children. So that is the goal of this study. We're interested in identifying potential dual oral language profiles in a sample of school-aged Hispanic Spanish-speaking children designated as English learners by their school district. We hypothesized that we would observe at least 3 types of language profiles, including a profile where there's high proficiency in Spanish and low proficiency in English, so Spanish dominant, a second profile with high proficiency in English and low proficiency in Spanish, English dominant, and then maybe one or more balanced groups with different proficiency level in both languages. Our hypothesis was formulated based on previous findings. So in previous studies, despite the numbers and the types of profiles identified, these 3 types of profiles have been consistently revealed. Next, I'm going to talk through the methods of this project. So this project involves secondary analysis of data from a large-scale cross-sectional study that examined factors that influence language and literacy development of Spanish-English bilingual children during the initial school years. As part of the large-scale study, narrative retail language samples in Spanish and English were elicited from participants using a wordless picture book, Frog, Where Are You? Spanish and English narrative samples were then transcribed in SALT, specifically following the conventions for bilingual language samples. A subset of participants from the original study were included for this study based on the following inclusion criteria. First of all, we include a child if they contributed narrative samples in both English and Spanish. Second, we have some criteria regarding the samples, so each narrative sample needed to include at least 5 complete and intelligible utterances, and with 75% or more of the number of total words produced in a target language. The final data set included 847 Spanish-speaking English learners. They are roughly balanced across sex and then distributed between kindergartners and 3rd graders. We used a method called the latent profile analysis, which is a type of finite mixture model used to express the overall distribution of one or more variables as a mixture of finite number of component distributions. I don't like it. We used a method called the latent profile analysis, which is a type of finite mixture model used to express the overall distribution of one or more variables as a mixture of a finite number of component distributions. So that was a mouthful, but there's a metaphor that I really like presented in Oberski 2016. So he described mixture models as the art of unscrambling egg, which I thought is perfect because it recovers hidden groups from observed data. So here, the observed data would be the scrambled eggs, and the hidden groups would be how many eggs that we put in. He also presented another example that I think would help people understand what latent profile analysis does. So for example, if a student went on a field trip and he recorded the height of everybody that he encountered, and then once he returned to the lab, he realized, well, wait a second, I actually forgot to record the sex of the participants. Because that actually matters because there's, instead of one distribution, as you can see here, that's the observed data, there's actually two different distributions associated with male and female. So with LPA, you are able to recover those hidden patterns. There are several advantages of LPA over traditional cluster analysis method. I've listed them here. For those of you who are interested in learning more about this method or who might be more technical or statistics savvy audience members, I've included several references at the bottom of the slide where you can learn more. So the measures we used in LPA included Spanish and English oral language measures calculated from the narrative transcripts. Specifically, we have 8 measures, 4 in each language. So these measures include subordination index, SI, which is a measure of syntactic complexity, moving average, type token ratio, MATTR, which is a measure of lexical diversity, words per minute, WPM, which is a measure of verbal fluency, and then narrative structure scheme, total score, which is a measure of Children's ability to produce a coherent narrative. We selected these measures because we think combined, these measures provide a broad index of oral language ability in each language. And so these 8 measures were collectively used in the latent profile analysis. We conducted all analysis in N+ and R. All models were estimated using maximum likelihood estimation with robust standard error. I included the argument, the syntax that we used, the N+ in the parentheses. And all models were ran with 500 random starts and 20 iterations to avoid potential invalid parameter estimates resulting from a local solution. On this slide, I presented a simplified workflow of the LPA model enumeration process based on Mason 2013. There are 2 dimensions where you can specify the models. The first is the number of profiles, so you can specify whether you want 1 profile versus 2, and you can gradually go up. And then the second dimension is the within-class variance-covariance structure, which means you can specify whether you want the mean variance or covariance to vary across profiles or constrained to be equal or 0 across profiles. So we started with a 1 profile model and gradually increased the number of profiles estimated 1 profile at a time until the estimated model ceased to be well-defined. So in our study, once we get to 7 profiles, even the model for the most parsimonious within-class variance-covariance structure stopped to be well-defined. And the idea of well-definedness in models is kind of similar to overfitting regression. So if you have a poorly defined model, we don't really have much confidence in how reliable or how stable that solution is. For each of these models on the left, we also enumerated through a second dimension of within-class variance-covariance structure. So let's take 1 profile model as an example. So we actually estimated 4 different 1 profile models, one with class invariant diagonal variance-covariance structure, one with class variant diagonal variance-covariance structure, one with class invariant unrestricted structure, and lastly one with class varying unrestricted structure. And that's the same across all of these. So if we go from 1 profile to 6 profile, and then we enumerate each of those along these 4 different types of variance-covariance structure, we actually have 24 possible solutions total. Now, because these variance-covariance structures are very long and hard to say, so we're actually going to refer to each of these models by ABCD. So a one profile model with the class invariant diagonal, we're going to refer to this as A1, model A1, and this would be model B1, C1, and D1. And we're going to adopt the same convention for 2 profile all the way up to 6 profile. So B2, C2, C3, D6. Once we have all of the 24 possible solutions, we used a 4-step procedure to select the optimal solution. Specifically, first we excluded models that were not well defined. Then we examined a variety of model fitness indices, including information criteria, relative fit indices, and model classification diagnostic information. Third, we compared each model against a benchmark model. And then lastly, once we have the optimal selected solution, we try to interpret the profile findings to confirm that the selected model is theoretically and conceptually meaningful and it's interpretable. Again, due to the time constraint that we have for this session, I'm not going to talk in detail about how we conducted each of these specific steps. If you're interested in how we kind of compared all of these indices and decided on the optimal model, here is the link to our preprint paper where you can read more about it. And you will also have my email, which I included on the last slide, so that if you have questions about a specific step, feel free to email me. I did include a couple slides kind of presenting all of the information, the indices, and try to walk you through the steps that we took visually. So feel free to take screenshots and study these. But again, you have our preprint and my email if you have questions. So after all of these steps, our optimal model was decided to be model C4. This is again based on the 4-step procedure, and we think all of the many of the indices converged on the solution. The optimal solution model C4 represents a 4-profile solution. Now let's unpack these results to understand the solution and the characteristics of each language profile identified. So in this graph, on the x-axis, we have the measures used in the analysis. So we have subordination index, MATTR, moving average type token ratio, which is a vocabulary measure, narrative scheme score, word per minute, in English on the left and in Spanish on the right. On the y-axis, we have the z-scores for each of these measures. And then the 4 groups that we identified are coded in color. So the largest profile we found is a balanced average group. So profile 1, this is plotted in blue line. So you can see that children in this group have relatively average performance across domains and across languages. The second profile is a Spanish dominant profile, which is plotted in red. So they have average Spanish performance, but relatively low English performance with a dip here in English vocabulary. So seem to suggest a particular weakness in English vocabulary. The third profile is the opposite of the second profile. We have an English dominant group. So exactly opposite, you can see here, average English performance and the relatively low Spanish with a similar kind of particular weakness in Spanish moving average type token ratio. And lastly, we have a balanced high group, which is profile 4, plotted in the green line. So as you can see here, the green line is consistently above the lines with all the other colors, with a particular strength here in Spanish syntax. I want to emphasize that I kept saying relative when I describe each of these profiles, because given these are z-scores, they're compared against other English learners in the sample. So everything we talk about, better or worse, is within the English learner sample. So in general, the profile characteristics we described here confirmed our hypothesis that 3 main patterns would emerge. We have a Spanish dominant group, an English dominant group, and 2 balanced groups with different levels of language skills in the 2 languages. In this graph, we get a different view of the same findings. So we have the same configuration, measures on the x-axis and z-scores on y-axis, but instead of plotting each profile as a color line and have them in one shared space, here we present each profile in an individual facet so that we can contrast language abilities within each of these profiles. As we're looking at these graphs, this graph, there are a couple interesting findings that I want to point out. First, I want to point out the presence of an English dominant profile in our sample of English learners. Now, this is interesting because within an English learner sample, it's common to assume that EL students have limited English proficiency, well, that's the definition, but we also tend to assume that these students have sufficient proficiency in their home language. So our finding here cautions against making a priori assumptions regarding the home language proficiency and language dominance patterns in English learners. I also want to add that in most states, the English learner identification procedure involves a home language use survey and then an English language proficiency assessment without testing students' proficiency in their home language use. As far as I'm concerned, I think there's only 4 states that encourage or require school districts to assess home language proficiency. So given these policies in place, we want to reiterate that we should not assume a student's language proficiency level in the 2 languages based on their EL status. Something else that we thought it was interesting is we actually found a group with balanced high abilities in both languages. So given these children in Profile 4 show the highest level of both English and Spanish language ability relative to other children in the whole sample, we are curious and we conducted post-hoc exploratory analysis to further understand the language ability of children in this profile. We want to know how they compare to monolingual peers, monolingual English-speaking peers and Spanish-speaking peers. To compare students in Profile 4 with monolingual samples, we used reference databases available in SALT. So SALT 2020 research versions comes with a variety of reference databases, both monolingual and bilingual are available. So your researchers can use these reference databases to better understand either their individual sample or to understand their data. So for us, we used 2 reference databases. One is a narrative story retell, and then the second is monolingual Spanish story retell. So both of these databases included narrative samples, either English or Spanish, from a similar age range, and then also using, I think, similar task, using the frog series. So for each narrative sample we have from students in Profile 4, we match them with a sample from either of these 2 databases. So we match them by age, grade, and language sample length based on the number of complete and intelligible utterances. And results are represented in this graph. To orient you to this graph a little bit, so now we have each measures in a different facet. English on the top row and then Spanish on the bottom row. The colors represent the groups. So students in Profile 4 is presented in yellow, and then the monolingual individually matched English reference sample is in blue, and the Spanish one is in red. So as you can see here highlighted in these green boxes, compared to matched monolingual English-speaking peers, children in Profile 4 actually achieved comparable levels of English syntax and verbal facility. So when it comes to Spanish, compared to matched monolingual Spanish-speaking peers, children in Profile 4 also achieved similarly or better on all Spanish measures. So they actually achieved significantly better than their monolingual peers in Spanish syntax and Spanish narratives. So it does seem like they're not just doing better within an EL sample when compared to their EL peers, but they're doing all right even when compared to monolingual peers. So to me, if you think about students' ability in Profile 4, and then compare that to, say, students from Profile 2 with a Spanish dominant profile, it doesn't quite make sense to place all of these children in the same classroom. All right, moving on. Something else that I want to point out when looking at this graph is that within each profile, we actually observe these uneven performances across languages and domains. So for example, other than the largest Profile 1. So for example, in Profile 2, we see a particular weakness in English vocabulary. In Profile 3, we see a particular weakness in in Spanish vocabulary. And then in Profile 4, we see a particular strength in syntax. So that's telling me that if I'm assessing students' language ability using a measure that only tap one domain, I may actually not get a representative view of their language ability across domain. Lastly, we looked at grade distributions across profiles. As illustrated in this graph here, we actually see children from kindergarten to third graders in each of these profiles. So for example, there are some third graders with a Spanish dominant profile, and then there are some kindergartners with in the balanced high profile. So this finding suggests that the variability we observed across Spanish and English skills in these children is not solely due to their age or school years in school. So though our study is limited by a lack of information on the history of participants' language exposure or current language use in their household, it will be interesting for future studies to collect these measures to better understand factors that contribute to different language profiles. So to summarize all of the findings that I have just described, first of all, we found substantial variability within a large English learner sample. If you remember, one thing from this 30-minute technical session is that bilingual children are not a homogeneous group. We have to start thinking about the differences within group variabilities within the sample. Specifically, in our study using latent profile analysis, we found 4 dual language profiles, a balanced average group, a Spanish dominant group, an English dominant group, and a balanced high group. Within each of these groups, we found uneven performances across language and across domains. And lastly, each profile also consists of children across grades. So now let's talk about practical and clinical implications. I think our findings here provide practical and clinical implications both at macro level, so educational policy level, and micro level, so individual teacher and classroom and clinician level. So on a macro level, we think that a dichotomous classification of English learners versus English proficient students based on a home language survey and an English proficiency test may not be sufficient to determine the type of educational program that best fits a specific bilingual child's need. Especially the variability that we observed in the study highlights the need to assess both languages to make an informed decision on selection of educational programs for bilingual children. Now, on the micro level, so teachers and clinicians, our findings suggest that a teacher in a transitional bilingual program may encounter a mixed group of bilingual children with drastically different language abilities across domains and languages. So findings from the study caution against making a priori assumptions on language proficiency in either the home language or English based on the EL status. And teachers and clinicians, when you're working with bilingual children, may also need to develop skills in differentiating instructions to improve the linguistic access of all students to academic content. So finally, some conclusions and future directions. So this study extends the current bilingual literature by demonstrating large variability in both Spanish and English oral language skills in a Spanish-speaking EL sample. Now this is a group of bilingual children often assumed to be homogeneous. There are several directions that future work can take. First of all, future work should test the replicability of language profiles in different subgroups of bilingual children, and also the stability of language profiles across grades. Now we are actually doing some current work to test the replicability and stability of the language profiles discovered in this study in the longitudinal sample. We think that refinements of the empirically based dual language profiles may facilitate the educational program placement procedure for bilingual children to more precisely identify educational programs best suited for children's linguistic needs. And we also think that for researchers, the dual language profiles emerged may also be useful to guide participant selection process to create better defined samples of bilingual children. So that's everything I have. Thank you so much for your interest in our work and for attending this virtual talk. This is the part that I wish we were in person and we can be more interactive and I can take your questions. So I've left my email here, and if you're interested in learning more about this work or if you have specific questions about any parts of my presentation, feel free to email me. Thank you again. Have a wonderful day. Bye.